happening. Firstly, we need to thank Alvaro and Jacob for coming on. So I'd like to thank them. And we organized this together with several user groups, Python Ireland, Ruby Ireland, and Dublin.net. And this is currently sponsored by these people, Python Ireland, Reinsurance, and Ruby Ireland. One more thing before we actually start, and I'll disappear. We're running code beers on every last Friday of the month. This time it's going to be the 30th of September. It's going to be in the Longstone. So I hope you get to say hi to each other here, and maybe we'll see each other again over there. The idea is polyglot programmers talking over beers, just because we're probably tired of talking about stuff within each other, just Python, just AlvaroVidela, just Ruby. You know, you get bored sometimes. So without anything else, I'd like to introduce Alvaro.
So thank you for coming, and thank you also for inviting me. I'm AlvaroVidela. I'm coming from Switzerland. I'm originally from Uruguay, and now I'm living there and working for Leap, which is a web development company in Switzerland. And that's my blog and Twitter and so on. And I'm also writing this book, RabbitMQ in Action, and we are about to finish. So in the real about to finish, like in every software project, you know, the 90% is the last half. To talk about messaging patterns, first I like to ask this question, like, why do I need messaging? And I always like to give like a very simple example from the web world, which is how to implement a photo gallery. So the gallery is very simple. You have a form where you select the picture, click upload, and then you will see the gallery with your pictures. I mean, very simple. So far this is okay until we start to get new requirements. So we have like a product owner now in this Scrum style of development, which comes to us and say, can we also notify the user friends when she uploads a new image? And suddenly forgot to mention that we want that for tomorrow. So we start to like the guy's mother and family and everybody. So then there is the social media guru, like the latest position in web development, who want to give badges to users for each picture upload. So again, more requirements. And also, you want to post uploads to Twitter. Then we have a sysadmin, or as I say, we have Swiss admins in Switzerland, which it say, okay, you are delivering full-size pictures, the bandwidth has tripled and so on, because we were asked to upload a picture and put it on an image gallery. Nobody told me that they want some thumbnails or something. So yeah, he want that fixed for yesterday. So it start to get a bit messy. Then there are people working in other teams, and our PHP staff need to be called from Python. I don't know, since there is people using Python these days. Sorry for the bad joke. And Java starting next week, or Ruby, or .NET. Then there is a user, and we also forget a lot about the user, which he doesn't want to wait that our application resizes the images. So most of the time we start adding requirements, and we start by coding the requirements, solving what we are asked to implement, but we forget there is a guy waiting on his computer on the other side of the network that actually doesn't care that you are in the latest social media, whatever, tweeting about his new picture upload, or I don't know. I mean, I just want my picture there. I don't care about your requirements. So we start to get like a lot of new things coming around. So then our part in the story can be resumed by these 3 letters. I hope you know what I mean. And yeah, let's see the code evolution. I mean, what happened with that simple image gallery? The code is some very pseudo code based in Erlang syntax, which is very readable. So we have a controller which is handling the put method for a user image path with some request data. We don't care about that. And yeah, it all started that image handler do upload and the file that we got on the request. Imagine this is working code and it doesn't matter for the example. Then, okay, we need to resize the image to not get killed by this sysadmin. So we got the image there and resize and continue. Then we need to notify the friends based on the user that is on the request data. And we also need to add point to the user so he will get a badge about if he's the top cool uploader of the week. And we also need to tweet about the new image based on the user information and so on. So what do we get out of this? Is can the code scale to new requirements? From my point of view, it can't, because what if we need to speed up image conversion? I don't know, we may need to go and rewrite this image resize thing to be parallel and distributed and whatnot. What if the user notification has to be sent via email? What if we don't need to tweet anymore? Let's say these Google people release a new social network and now it's more fashion to use this network than Twitter. So we need to go back there, remove that line of code out of the controller, put the new one. It's really a simple change, but why do I have to do it? Why I cannot have one way to implement that and think about the new requirements later? Also, what happens if we need to resize to different formats and so on? So can we do better? I guess we can, and it's by using messaging. So there is a pattern which is called publish subscribe, where we send an event on the system, and then, for example, in this case, it's called address change, and there will be 3 subscribers, and then each of them can do whatever they want with the event. So there will be 1 message entering the message system, and 3 messages going there, and we decide what to do there. So the first implementation of the solution will be, okay, we do the image upload, we get the image data, whatever that is, and we create a new message which, with the user information and the image, and then we publish the message to, let's say, a new image queue exchange or whatever your message system has. And then on the other side, on the back end, also we will write a friends notifier code there, which will receive this event, new image, and it will call the function notify friends, whatever that is doing. Then we have the points manager, which is another script, cron shell, whatever, which on new image again will do add points. And finally, we have the image resizer, which again will do that. So is there any second implementation? No, there isn't, because this was what we were required. We made our code message enabled. So after the publish message, we don't care anymore. We just fire and forget, as they say, and then we have all the subscribers. And if we have new ones, we just add new ones. If for some reason we don't need to give points anymore to the user, we just stop this one. These other 2, they don't know. Of course, in this example, I'm not considering the case where to notify the friends, I need to be sure that the image was resized, for example. It's a very simple example. You may need to have interdependencies that you need to solve also by messaging. So, messaging is used to share data across processes. They can be part of different applications. They don't need to be inside the same application. You can use it to communicate across them, and of course across different machines on the network. And the communication is asynchronous. So even if we can have a fake RPC implementation using messaging, actually everything is asynchronous. The message may not arrive never. So that's something we have to take into account when we use messaging. So then the messages are sent by producers, received by consumers, and they are sent on a channel. All this based on the Enterprise Integration Patterns book. This is the terminology used. So basically what will change from message system to message system is what is the channel. So we will see what this means for RabbitMQ, but like in Microsoft MQ, I think you just have queues, and I don't know, in JMS or the other systems, but basically what you need to adapt depending on the situation or the pattern is the channel concept. So messaging and RabbitMQ. So what is RabbitMQ? Probably you know it or don't, I don't know. So it's branded as an enterprise messaging system, it's open source, it's written in Erlang, has commercial support, and the messaging is done via ANQP. You can also use Stomp or other protocols, but ANQP is the default one. And when in my previous company we decided to use RabbitMQ, those were some of the reasons why we choose it over other solutions. You may wonder, for example, why written in Erlang is so important. It's because it's the latest language that people is talking about, or there is a reason behind. In the case of Erlang, it has this OTP framework, which is made for concurrency, so I'm happy if the RabbitMQ guys are not rewriting or reinventing their new concurrency framework and introducing bugs and so on, because, yeah, I mean, we need to test the software and get some concurrency framework battle tested there, so it's easier if they use a language which is made for that. Then of course to have an open source broker is better and easier and so on. Commercial support in case we grew with our messaging needs and so on. Then RabbitMQ is very reliable. When we were using it in a dating website for Germany, we never had trouble with it. Then it's very easy to install. If you have Erlang compiled in your system, you can get Rabbit running in 20 seconds, depending how fast you type, but it's really, really easy. It's very easy to cluster, also thanks to Erlang, because Erlang has a distribution system, so if you have many machines and you can make these Erlang nodes talk, RabbitMQ will run on top of an Erlang node, so it will be able to cluster with other servers. Then also thanks to Erlang, it can run on all these platforms, so whenever you can run Erlang, you can run RabbitMQ. And it supports these two versions of the ANQP protocol. Okay. So there are many client libraries in RabbitMQ. There is the Java and the .NET and C# libraries, which are the officially supported ones. I don't know if the ANQP one is supported by the Rabbit guys. The ANQP library in Ruby.
Oh, the library.
Is it official? Or?
Well, it's official.
Okay, so
mostly.
So the Ruby library can be moved here. There is an Erlang client also written by the RabbitMQ guys, but it's not officially supported. So it may break and may not, so it depends. And then there are all these other libraries for these languages, and they vary in quality and what you can get. I think also there is a Python library also by the RabbitMQ guys.
Yeah.
It's Pika, and also there's Puka, and maybe they're playing with vowels. I don't know. So what is ANQP? ANQP stands for Advanced Messaging Queuing Protocol. It was made for interoperability. Why? Because like before, all like the guys like JP Morgan and all these big players, they were all tied to the IBM implementations or Microsoft or whatever, and they were spending a lot of money making solutions that allowed them to talk with these queues. So they say, okay, let's try to create something where we can have like an open protocol. So they went for ANQP. And yeah, it's a binary protocol, so has a specification on how to encode integers, how to encode strings, and all of the stuff. If you want to implement a library, probably Jay Cook can know more about that. So the message flow in ANQP, as I told you before, we had producers and consumers. That's okay, but in the middle we have the broker, and inside the broker we have many components. So one thing to make really clear is like messages are never ever delivered to queues in ANQP. They will always go to an exchange. The exchange will have a routing table, which are the bindings, And this routing table, we have maps from origin to destination. The origin is the exchange, the destination is the queue. So if the binding, if this routing matches, is where the message will finally arrive, or maybe even dropped if there is no way where to put it. So you can imagine that as like when you have your inbox and your rules for like every message will arrive to your inbox, but if you put rules, then they will go to a folder called Awesome Conference in Dublin, I don't know, and maybe this one was filtered to trash, I don't know. And yeah, so the exchange is there to decide where the messages will go. We will see what are these bindings and so on. So then in the model you have all these, the exchanges, message queue bindings, and then the rules for binding them. There are many exchange types. The three most important, I would say, or popular are the fan-out, direct, and topic, which are an AMQP broker must implement those exchanges. So what is each one? The fan-out exchange, whenever you get a message, you will have again the bindings. Every queue that is bound to the exchange will get a copy of the message. So before, when we saw this publish subscribe stuff, you can achieve it with the fan-out exchange. You send all your new image messages to this queue, to this exchange, and then you bind a queue, resize picture, another queue, notify friends, tweet, send email, and so on. If tomorrow you don't want to get messages anymore, you unbind the queue. Then the direct exchange is similar, but you use a routing key. Whenever you publish a message, you will say, okay, put it in the exchange, new image, and using a routing key. So if the routing key matches the one in the binding of the queue to the exchange with the one coming with the message, then the message will get to that queue. Else it could be dropped, depending on how you configure your publisher, for example. And then this exchange is pretty cool, I think, is the topic exchange, where you have many routing keys, and then those routing keys will be used as patterns to match bindings. So for example, this queue here, which is interested on every event that happened in the States, like news or weather. Why? Because it's using this sharp there. So the sharp matches more than one word. So yeah, all these messages will go there. But in this case, it's interested in news only. So we get news from Europe and from USA, the same one from weather and for Europe. So maybe this seems a bit, I don't know, what can I do with that? But if you are building a login platform, for example, you can log your messages, and the routing key could be like hostname .application .module .error level, and then you can fire a new consumer, which will create a queue only to get all the errors happening in your cluster, so all these messages will go there. But then you're only interested because you got an alarm that server 1 is down, or has some problem, so you fire up a queue listening to server 1.sharp, for example, and we get everything that was logged via that, using that routing key. Then the advantage also is like if tomorrow, I don't know, suddenly people care about South America, you can have SouthAmerica.news, SouthAmerica.weather, and you don't need to do anything. Just publish messages with the events and get a new consumer, and then we don't care anymore about South America because they only play football there. So what else could happen? So you remove these consumers, and yeah, nothing changed. I mean, you don't need to do so much maintenance to keep them going on. So finally, messaging patterns. This was all the introduction to get you here. So there are many. There is like a Bible-sized book called Enterprise Integration Pattern. The good things or the good news for the .NET guys is like this book has examples in .NET or Java. Forget about the Java part, but you have .NET examples. Yeah, and then its target is JMS and Microsoft MQ. So you need to translate the examples to whatever messaging system you're using, but it's not so hard. But I really recommend this book if you are into messaging. So there are basic patterns which you build up from them to go further. So the most basic one, I didn't know there was a name for this, but it's called competing consumers. So it's how you can process messages concurrently. I will share the slide later, so don't worry so much about this text. So you can create many consumers for one queue. So you, for example, you want to resize images in parallel. As we said before, without messaging, you may need to synchronize in a database, or I don't know, do some stuff that you probably will have some headache maintaining later. And in this case, in the case of RabbitMQ, you will publish the messages and you will make sure they arrive to some queue. And there you will get all these competing consumers. Why competing? Because they are competing for the message. So as you see, the first two messages will go there and the other one will go down there. So before, when we saw this publish subscribe, that we sent one message and this message was distributed to 3 queues, on the other end you can have many consumers for this queue. So you have a publish subscribe, but on the other end you have competing consumers. So you can always compose this pattern the same you do with the OOP pattern. So the code in RabbitMQ specifically, you will need to declare an exchange. So there is a command in ANQP called exchange declare. Depending on your libraries, how will be this method called. I don't know what the standard for .NET or PHP or Ruby are. But sometimes it's got camel case or snake case or whatever. So you will provide the exchange name, the type, which is direct, and you make the exchange durable. For example, this means if the server restarts, the exchange will still be there. Then you declare a queue. You can say it's not durable, and you give the queue name, whatever was passed to this function. And then you do a bind. So the binding will be the queue and the exchange, and if you don't provide any routing key, RabbitMQ or ANQP will assume you're using an empty routing key. So with that, you got ready you got all the elements in the server, in the broker. Then you can publish messages. So you create a message with some properties, which you can omit if you want. So for example, this one will have a content type of JSON, and then delivery mode will be 2, which in an ANQP means persistent. So this message will be persisted to disk. And then you publish the message to an exchange, and using the message properties and some payload that you pass there. So that is all. Of course, you will abstract this code, so you won't be doing this every single time you need a queue or an exchange or a binding. So you will have an init method, or I don't know what you prefer. And yeah, that's all. So basically, you will care about encoding, setting the message properties, and publishing. Then on the other end, when you have the consumer, again, you initialize everything, like calling the previous function, and then you just do basic consume from which queue you want to consume. In this case, that's the only property, but in ANQP, you can say, okay, I want to consume messages, and I won't give any confirmation to the server that I consume the message successfully. So the server will deliver the message and forget about it. But if you say, I want in the default mode where you are actually acknowledging the messages, the server will wait for your consumer to send the ACK back to the server. And then you will set up a callback, or I don't know, in .NET I think you have events, I'm not sure. So whenever the server delivers a message to your program, you will get the message itself and some delivery tag, which is a way to identify the message. So you will do something with the message, and you will acknowledge that you did that, whatever that was. Then this code can be run only in one process or in many processes as you may need, depending on amount of jobs you need to process. You can even run this in many computers, and RabbitMQ will take care of doing all the round robin across consumers, sending the messages to each of them. Every time some of the consumers acknowledge the message, we get a new message and so on. If somebody fails, the message will go back to the queue, and of course it will be out of order. So sometimes people ask in the mailing list why Rabbit doesn't keep the order, but it's very easy. I mean, you are consuming messages, and then some message come back. Of course, will be out of order because the others were consumed already. So that's the very basic competing consumers pattern. Then you have the publish subscribe that we saw already. So yeah, we send one message, then we send too many queues, and then we can have competing consumers there also. The only difference that we have is that we have a fan out exchange instead of a direct exchange. But then we just publish the message the same way we did. That's why I was saying that we need to write a library that will abstract all that for you, because you don't want to do it all the time. And even you may want to write a DSL for your own application, so your other developers, they don't need to be learning all this AMQP stuff. I don't know. So, and then on the consumer, one consumer, for example, can be resizing the messages based on some resize image queue. Another one can be the notify friends and then call this function here, and so on. The log, for example, a new requirement was to log every image upload, so you created a queue, log image, the queue got bound to the exchange, and then you log the messages. So then, something like sometimes how do I implement that on AMQP is the request reply pattern. Like, okay, I'm sending messages to the consumers, I'm consuming something there, but I need to get a notification that something happened, or I may want to have a server that is doing some calculation for me and then give me back a result, and so on. So there is, of course, the request reply pattern, which you have an exchange, which will be the request exchange, where you send the message, and then the server will know that it needs to reply to the reply exchange. That's pretty simple. Of course, you can have many competing consumers there processing the messages that you request to the server and so on. But this doesn't scale because you can only have like one client for your server, or one kind of client. So the reply channel is hard-coded on the server, so the server is kind of not useless because it will work, but you can have dynamic client, for example. So for that, there is this other pattern, which is return address, which is simple. How does a replier know where to send the reply? So in AMQP, you have the reply to property. So whenever you send a message, your requester will create his own queue there to get the messages and the exchange and whatnot. And he will send the message to the server specifying the reply to address. And the same will happen here. So then the server will know, will inspect the message headers and say, okay, this is the reply to address, I will send it there. But there is another problem, which is now this client can only work with that server and can work only sequentially. So in the case of PHP, for example, maybe you can apply that to Ruby or Python. You are serving a website and then you have like one database query that takes, I don't know, 5 seconds. It was the super query. And then another one takes, I don't know, 1 second, and then you need to wait 6 seconds while you do all sequentially. But if you could fire everything in parallel and get the replies back, at least you will have a small speed up. But in this case, you cannot do that because still you need to wait the reply sequentially. So there is another pattern, which is the correlation identifier, where the publisher will add the return address to the message plus a request ID. So then, yes, it can send all the messages to this server or to many servers, doing separate things, like you can have one server counting words and another server, I don't know, returning some other information. And then based on the correlation identifier, you can have a hash in memory waiting for replies, and then you match that to what you got, I don't know. So this is all blurry, but let's see how it works all together. So the RPC client, it has its own queue, and then it will have this exchange. Yeah, sorry, the queue, sorry. Because in AMQP, this is a bit, so in AMQP you can declare queues, and you can give the name to a queue, or you can have a name assigned by the server, for example. In this case, you can have your own queue, and then you can say that it's exclusive and auto-delete. What does that mean? Is no other process can consume from this queue if the queue is exclusive. And whenever this process dies or is killed or whatever, this queue will get removed from the server. That's the auto-delete. So in this way, we keep a clean installation of RabbitMQ. For example, if you have many PHP processes serving requests, and then for each user that arrives to your system, you create a new queue. Imagine that after an hour, you have millions of queues there, and yeah, it will be a real mess. And yeah, you save that by doing the auto-delete. And with the exclusive, you keep that the messages arrive to you, only you, because it's your process doing the request. And then here, you will do the consume, and then you don't need to acknowledge, because if this message is not consumed by your process, then it may not be worth for another process in the system. And then you keep this queue in memory. I mean the queue name. Then whenever you do a request, you will send the server the queue name and a correlation ID on the message headers, and then you publish that to whatever is the server exchange. And finally, when you get the message back from the server, you will get the correlation ID back from the message. So the server needs to make the contract that whenever it gets a message, it will extract the correlation ID, calculate the reply, and put it back. So as a client, you know what's what. And then you will do something with the reply. So the server will get a message, I mean your request, will extract the properties and the payload. It gets the correlation ID out of the properties. It will get the reply to out of the properties. We'll do something with the payload, calculate the reply, and then we'll set the correlation ID based on what was here, and then it will publish it. And this is something specific of AMQP. In AMQP, there is an anonymous exchange, which every queue created in the system is bound by default to that exchange. And the routing key is the queue name. So if you send a message using as routing key whatever was the queue name of the client queue to the anonymous exchange, this message will go to the queue. So this is the way to send a message directly to a queue as direct as you can. But still, the message is not going straight away to the queue. It will be routed by this exchange. So that's something particular of AMQP on how to implement the RPC part. Do you have any questions so far?
Is there a common place where you define what's in the messages?
Sorry?
Is there one place where you define what's in the messages, like what fields are supposed to be present?
No, that's something you need to agree in your application. Also, the way you encode, you can have the content type saying what's what, but there is nothing like that. Any other questions? I hope you're understanding. So then the advanced patterns, I don't want to bore to get you so bored with that, but the problem is like when you have a message system and then you start to use all these patterns or use messaging in your application. What happened to us in my previous work job when we were doing messaging for this dating website, it was like, okay, but did the message arrive? Where is the message? How many messages are going on? And like, what is the content of the messages? Is the server replying properly? And there are many questions that you start to have concerning how to administer the server. So one pattern is the control bus, which has many functions. It's not just one thing what we implement. We can add many aspects of this control bus. So these aspects are like you can send configuration messages, you can start or stop services, you can inject test messages, you can collect statistics. So for example, in RabbitMQ, you have the management console where you can see which queues you have in the server, which exchanges, what are the bindings between queues and exchanges, how many connections you have, how many channels on those connections, and so on. So you can do mostly this part with the management console, plus all you can know what you have on the server. The others you need to code it yourself, basically. So you will have your normal message flow in your application, and then you have this control bus doing whatever you think you could do. Like I know in Microsoft MQ you have a small application where you can see what you have also in your system, but then there is not so much done about this area as far as I know. So the idea is to make your services control bus enabled. So for example, in the case of the RPC server, you can have a process that every minute is sending a test message to the RPC server. So if you have a count words server, like some sentence has 5 words, I don't know. So you send this 5-word sentence and you expect the 5 back. Then at the same time, if the reply, you set up a new timer, and then if the reply doesn't arrive in, say, 5 seconds, it means the server is down, because you expect that the server is replying every 4 seconds. I don't know, it depends on your application. So in that case, with your small process that is injecting test messages, if the reply doesn't arrive in these 5 seconds, you send a message to the control bus saying, server blah 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 is down. So in your console, you will see the server is down. But suddenly, for some reason, the server replied back, so a new message to the control bus, server I don't know what is back up, and so on. Then, for example, you have this one sending messages to this component and so on, but for some reason, the server having this component went down, or it needs to be down for maintenance, or I don't know what. You can send a message from the control bus to this component saying the new publication address is this one. And then you don't need to stop this component, and you make it send the messages to this other place. That's what I mean by having these services control bus enabled. So you have a publisher which knows where to send messages and so on, but at the same time this publisher has its own private queue where it listens from notification from the control bus. And then maybe in a web console or something you can check all these messages. So one of these patterns that you can make use of the control bus is the detour. So in the case that you need, for example, to debug your messaging system, so you cannot stop it, but you need to know if the right messages are flowing around the network. So in the detour, you have the source, which is sending messages to the destination. That's very nice, but how do I know what's going on in the network? Or you need to do some TCP dumps or something, but that's not elegant. I mean, your sysadmin may want to do it. So, in this case, you have the control bus, and then you can send a message saying, okay, you have this component in the middle, which is just acting as a proxy. But whenever you inject a message, you can say, okay, go this other route on top, and here you can dump the message content to some console, do something else with the message, and send it to the final destination. And then whenever you finish debugging, you can send a message again, and then the route will change and will continue in the normal flow. If, for example, your source was also control enabled, you can also send a message here and say, skip all this debugging process and send it straight away to the destination. So you could do all this kind of stuff if you have the control bus in place. So then another one is how to inspect the messages. So for that you will use the wiretap, which, yeah, you have this component in the middle, and then every message that goes by will be wiretapped and sent to another queue. In RabbitMQ, I think since one of the latest versions, you have this implemented already on the broker, so you don't need to do it. Then, for example, a guy extended the RabbitMQ exchanges, so you can have like a React exchange to use this NoSQL database. So every message that will go to those React exchanges will go to the normal MQP flow, plus it will be logged to a React database. So yeah, you can do whatever you want after that. And yeah, keep in mind that in RabbitMQ, the queues are queues as in a data structure point of view, yeah, sense, whatever, where the messages are queued in the queue. So you cannot browse the queue, because to browse a queue, you need to the queue stuff. So because you're the queuing stuff for consumers, in RabbitMQ, you cannot browse queues. So if you want to do that, you will need to have this particular exchange and sending stuff to React, for example, or implementing that yourself, or having this done with the new component in the broker. And finally, this is the most crazy pattern, I think, with all the components you have in the middle. So it's used to measure the speed of an RPC server, so you can know if it is working properly according to your requirements. Of course, all these patterns will add a small overhead on your system, but for example, RabbitMQ in this computer can pass around 12,000 messages per second, so it should be fast enough, I guess, depending on what you want to do, of course. So, yeah, what is the smart proxy? So, you are sending messages to the RPC server, but you want to really measure what is the speed of the reply of the server and see the status and so on. So the smart proxy, what it will do is to get the message, so the requester will believe it's sending messages to the server, but actually sending to this component in the middle. Then here, it will extract from this message the reply to property plus the correlation ID, and will keep that in memory. Will create its own request with its own correlation ID and send it to the server with its own reply to property. So it will have a map from my correlation ID as a smart proxy to original correlation ID, original reply to, plus the time when the message arrived. When the message comes back here, from the correlation ID, we'll go to this map, get the properties, and measure also the time. And then we will collect all these statistics in memory. And then usually every minute or so, half a minute, I don't know, depending on how many messages you are passing around, it can send all these stats to the control bus. So I did a small experiment for this pattern, like I had a web application in PHP, then the RPC servers also in PHP, all in this computer, and then I started sending messages like if I have many users browsing the website, and I could measure that the speed was about 2 milliseconds to do whatever the RPC server were doing. So you can, in that way, you can collect all these stats about your server. So here, for example, you can have this process measuring the speed of injecting test messages to the service and waiting for a certain period of time to know if the server is replying fast enough and so on. So all these drawings are from the book, this enterprise architecture pattern, and they are like a Creative Commons license, so you can use it for your own architecture drawing and so on. And there are also stencils for, like I think, Microsoft Visio and this Mac OmniGraph or something. So you can do all the architecture things. So I don't know if you have any questions, but thanks for listening.